Hey guys, welcome to my channel, Math for Teens. In today's video, we're going to be doing a deep delve into combinatorics. And so the goal for today's video is for you guys to intuitively understand and be able to derive the equations of combinatorics. This is a super useful skill because realistically, you don't want to have to memorize formulas when they can be easily understood. Okay, so I'm going to do this using this one problem I didn't generate. Google AI generated. So we're going to explain it from here. So basically, you have 2 women and 5 men. And you want to know how many ways can you make a group of 3 people such that each group has at least 1 woman. Now, clearly, the most a group can have is 2 women. And if a group has 2 women, that means we have a single group, right? If you had 2 groups and one of the groups had 2 women, the other group would have no women. There's only 2 women to begin with. So I think I'm just going to go case by case here. So in one case, we have a single team. So one team means we have 2 women in that team and we have to pick a 3rd member, which is going to be a man. And how many options do we have for that 3rd member? Well, there are 5 men to choose from, which means that we have 5 different groups we can make. So here, if there's one team, which means both of the women are in that team, 5 ways we can make such a group. On the other hand, if the most teams we can make is 2 teams, right? Because in 2 teams, each of the teams has 1 woman. If there were 3 teams, there wouldn't be enough women to have a woman in each of the teams, right? So the second case and the final case is when we have 2 teams, we have 1 woman. So if we just consider let's consider per each team. We have 1 woman, so we need to find 2 men to put in the group. So now the question becomes, from 5 men, how many groups can we make? How many groups of 2 can we make, right? So group 1 has the first woman, we'll call her Lori, right? So we have Lori, and then we have 2 other candidates. And now we're going to begin the explanations, okay? So I have 5 guys. That means that if I just want to know, like throwing out the window, overcounting, and all that stuff, how many groups can I make with 5 guys? It's like if you have 5 marbles, and how many groups of 2 can you make? You pick out the first marble. How many different ways can you pick out the first marble if there's 5 marbles in total? Well, you have 5 possibilities. You have 5 ways to choose the first guy. And now, for your second guy or second marble, how many do you have left to choose from? Well, you have 4. So 5 times 4 equals 20. And now some of you might be like, well, why am I even doing a multiplication to begin with? And I'm going to get a bit sidetracked and use a fruit analogy. So imagine you have a banana, like this. You have an apple and a star fruit, if that's a thing. And you want to know how many groups of 2 can you make from these 3 fruit, right? 3 fruits? Yeah. Okay. So let's also do the same analogy. For your first option, you could pick either one of the 3 fruits, right? And then let's say I had picked the banana, I would only have 2 options left, right? And so in total, I would have 6 options. 6 groups, right? And let's also visually do this. If I picked the banana first, what could I do next? Well, if I picked the banana first, I could either pick my apple or I could pick my star fruit. If I picked more colors. If I picked my apple first, now I could pick my banana or my star fruit. And finally, if I picked my star fruit first, I could then pick my apple or I could pick my banana. You guys are probably like, well, we're doing some overcounting here, right? This group, banana and apple and banana, is the same thing. But right now, we're forgetting about overcounting, okay? This basically is just a way of understanding why you're doing multiplication. With each fruit I pick, I can then pair it with two other fruits. So for each fruit, I can make two groups. And so for each first fruit I pick, it can make two groups. How many fruit could I pick at first? I could have picked the banana, I could have picked the apple, or I could have picked the star fruit. So there are 3 different fruit I could have picked, and for each of them, I could make 2 groups. And so in total, I have 6 groups that could be made, right? I'm not assuming I picked one first over the other, it's just all the possibilities out there, there are 6 groups that can be made. Now, of course, we're doing some overcounting here, but maybe let's address that now. Hopefully you guys understand this multiplication. If I want to know, well, how many groups can I actually make, right? Like, I don't want to consider, if I take the apple and then I take the banana, I know that that's the same thing as me taking the banana and then the apple. So I don't want to count that group twice, because right now I'm counting it twice. I'm counting, well, I could pick the banana first and then pick the apple, or I could pick the apple first and then pick the banana. And it's basically saying, well, those will be 2 different groups. I want to nullify that. I want them to be the same group. So now I need to ask myself, well, how many times am I overcounting, right? And so the way to do this is basically, I know I'm trying to make a group of 2. So for each group, if I have 2 objects and I want to know how many different ways, how many groups can I make out of them, this will tell me I have 2 objects, right? So I could pick either one of the 2 objects first, and then I'll have one option left to pick from. That tells me I'll have 2 groups I can make. I know that's not the same, right? Sorry, not the same. I know that's not true, okay? So I know that I'm overcounting each group twice, basically. This is what it's telling me. It tells me if I'm making a group of 2, how many ways can I overcount a group of 2? And this is what it tells us. Well, I don't know if I explained this properly for you guys. Let's maybe do some more drawing. So in this group with my banana and my apple, I want to know. I know I overcounted, but how much did I overcount it? Well, right here, just considering this group of 2, I want to know how many groups can I make out of it. I have 2 objects first. I could either pick my banana and pair it with my apple, or I could pick my apple and pair it with my banana, right? So for my first draw, I have 2 options. For my first draw, I have 2 options, and for my second, I only have 1. And this is telling us how many ways we can make a group of 2, and thus how many times we overcounted each group of 2. So if I counted each group of 2 twice, that means that, once again, every single group here was counted twice because it considered order. So I know that the actual number of groups where order doesn't matter, right? Where picking an apple and then a banana is the same as picking a banana and then an apple. I know that that will be half the number that I got because I know that each group was doubled, right? So if I divide it by 2, I'll get to the actual number of groups. So the actual number of ways I can make groups of 2 with these 3 fruit is just 3 ways, right? Okay. So this logic is what will bring us to the equations of combinatorics, which you may have seen and been like, well, what is that? But it's actually really simple, right? Once you take the time to just become familiar with the thought process. And so, for those of you who don't know, the equations that I'm referring to for combinatorics, we have the number of ways. Well, okay, I'll just write it. I have n factorial divided by n minus r factorial times r factorial, right? So let's apply this formula over here. Let me see if I can somehow move this, because, yeah, there we go. Okay, so what is this formula telling us? So what it's telling us is that if I have n objects, right? So here I have 3 fruit, and I want to know how many ways can I make it into a group of R elements, right? How many ways can I organize these fruits into a group of 2? And this will tell us how many ways. So here n is the total, so n is like the total number of fruit you're dealing with equals number of fruit total, and R equals group size, right? Why does this formula make sense? So the way to read this formula is in 2 parts. So first you read all of this together. What this is doing, I think to explain this part, I'll use this over here. When we were seeing, without overcounting, with overcounting, how many ways can I put 5 guys into a group of 2? And now you know, well, this is not the correct number, I'm overcounting clearly. And actually we can simplify this right now, because I know the group size is 2. So if I want to put objects into a group of 2, this tells us how many ways you can overcount that. So it will consider, if I have James and then like Guy, it will count James and then Guy as a different group than Guy and then James, right? So there's 2 ways of overcounting each group, and so the actual number of groups will be half of this. The actual number of ways I can put 5 guys into groups of 2 is 10. And so what I just did here is actually all of this, but this first part was this 5 times 4. I was completely ignoring that I can overcount. It's just, without overcounting, how many ways can I put these guys into groups of 2? That's what the yellow here is. What it says is that, well, first, I'm sure you guys know what a factorial is by now. It's just like if I say 5 factorial, it's 5 times all of the natural numbers with like less than it, right? So 5 times 4 times 3 times 2 times 1. That's what factorial is. So if I just follow this formula, I have 5 times 4 times 3 times 2 times 1. What this is telling me is how many ways can I organize 5 guys into groups of 5, right? because here I'm saying, well, this was my first choice, this was my second choice. My second choice, one guy was removed, I had 4 left. My third choice, there's only 3 guys left, and my second choice, there's only 2 guys, and obviously my last and 5th place in the group, there will only be 1 final guy left. So this is if I'm making a group of 5, right? So there are 5 guys in this group. In my group, though, over here, I only want 2 guys in a group. So what is this saying? Basically, let me erase this 5 over here, but in my denominator you see n minus r factorial. Now remember, r is the group size. Group size here is 2. So 5 minus 2 is 3. So what I'm going to do is divide all of this by 3 factorial, which is 3 times 2 times 1. Oh, and what do you notice? The 3 times 2 times 1 cancels with this 3 times 2 times 1. And you just get the 5, 4 you were looking for when the group size is just 2. So basically, your n minus r considers, after my group size, which is just 2 guys, I have a leftover, which is what I'm trying to get rid of that. And so when you divide this leftover by the leftover, right, it cancels. And so you just get 5 times 4. I hope that makes sense somewhat to you guys, but yeah, it's just a nice way of making it cancel, right? If I have 5 guys, I got rid of, basically, I have 5 times 4. I got rid of the first 2 elements. 5 minus 2 gives 3, 3 factorial, and that is how much, those are the elements I don't want to use. I'm only looking for groups of 2, not groups of 5, and so it cancels, and yeah, I'm left with what I need. So hopefully that makes sense for you guys. That was the part in yellow, and then you maybe have guessed it. What is this r factorial doing in the denominator? Now that's where we overcount. R factorial, remember, is group size. And so if I have, so group size, I have 2 people, so over here I had 2 guys per group of 2, right? And I want to know how many ways am I overcounting each group of 2, and that will be r factorial. It's the same logic like we said, but maybe you're like, well, why is it r factorial? How do I know that the number of people in the group is the same as the number of slots? And maybe we just add a fruit to just add like a box, right? And I want to make a group of not 2 but a group of 3, right? What would I get? Well, I would have 4 times 3 times 2, right? Ways of making a group, period, right? The first fruit, I have 4 options, and 3, and then 2. So 4 times 3 is 12, that's 24 ways of making groups, but it's overcounting, right? For each group of 3, I want to know how many ways can I overcount that. And of course, just logically, I know that I'm having, I don't know how else to say this, but I have 3 people. That's the reason why the group size is 3. The group size depends on the number of elements. Total elements becomes the number in the group. That's what it means when I want to, when I'm considering how many am I overcounting by. So n is equal to r here, and so yeah, that kind of equation makes no sense here. I know that was a bad explanation. I wish I could explain it better, but maybe it makes logical sense to you guys as well. Okay, yeah, so that's kind of where this equation gets derived. Obviously, the r factorial, we understand that that's to say how much am I overcounting from? How many ways can I make a group? Can I make the group of that group size? So if group size is 4, how many ways can I order 4 people? And of course, those 4 people are going to be going in a group of 4. I only have those 4 people. They can't make a group of anything else, right? Yeah. Because the R factorial is all about considering how many ways can I organize the people in this group size. So the number of people is the size of the group. Yeah. Okay. Well, hopefully this made some sense for you guys. And yeah, catch you guys in the next video. Thank you for watching.